Okay, friends, I've made a short video on velocity, acceleration and rotation. But before moving on to the video, I would like to talk something about myself. You see, other than code, the only thing that I like as much is cars. And this week's topic has given me ample opportunity to include cars in my video. But here's the interesting bit. I don't have a single car in my code. You won't be able to see any car in the programming. I have, instead of cars, yellow circles, which will be the representation for my cars. Okay, with that, we move on. Um, in this video, I've tried to bridge the gap between the concepts of real world like acceleration, retardation, deacceleration, and show that how we can implement them in the computer world, that is, programming. Um, so um, these concepts are quite simple: displacement, velocity, acceleration, retardation. The thing which I would like to point out is that acceleration is along the direction of motion, whereas deceleration or retardation, that's against the motion. It opposes the motion. Um, so let's take you to the four programs which I have made to demonstrate the simple fact. The first program, the yellow circle is my car. I would like you to have keep your eyes on this portion which shows which key I'm pressing. Okay, so I press the up arrow key. The car has shifted its position. But wait, it doesn't look like a car. It's like a frog leaping ahead. I didn't want a frog, I want a car. Hmm, let's see. Well, the motive of this program is to show that if I periodically change the velocity of a body, it can be if I periodically change the position of a body, it can be looked upon as velocity. So if I periodically change the position of this yellow circle, this can be looked upon as a velocity, a moving car, a moving ball. If I press the down arrow key, the ball moves downwards. Good enough, it has a velocity, although we see the time lag between two presses. Had the computer done this work, it would have been much faster. So we would have been able to look upon it as velocity. So we move on. Okay, so we see the code. The code's quite simple. I have a function position update, which updates the position of uh, the circle depending on which key is pressed. If the up key is pressed, the position is shifted upwards uh, by a particular shift value, 10 in this case. The circle gets shifted um, forwards by 10 pixels. If I press the down key, it gets shifted downwards by 10 pixels. I have a key handler function which reads which key I'm pressing and pass on the control to position update. So with that, we see the next program. In the next program, I have tried to show that if we increase the velocity of a body periodically, it can be looked upon as acceleration. So I have the same setup, but this time I have a speedometer. Okay, so if I press the up arrow key, the ball moves to the final velocity. If I keep pressing it, the velocity of the ball is periodically changing, and this can be looked upon as acceleration. You also saw that when I pressed the up arrow key, throttle got printed over here, and if I press the down arrow key, brakes is getting printed, and the car is slowing down. Um, in this program, it's just a modification of the previous code. Um, I just have a global variable y equal to 0 uh, to see whether I'll increase the velocity or I'll decrease the velocity. I also have a new function, velocity update, which increases the velocity by amount ACC. ACC is preset to 1. ACC represents acceleration. the velocity is increased by ACC if the throttle is pressed. The velocity is decreased by the amount ACC if brakes are pressed. The rest of the program is quite similar. So we go to the third program. But before that, let's move on to OneNote. Okay, so what's the reason behind acceleration and retardation? The reason behind these two things is force. Whenever you have acceleration or deceleration, you will have a force causing it. So in this case, I have a fighter plane. You see the gases coming out of the exhaust. They exert a thrust on the plane that causes it to surge ahead. In the case of the pickup truck, the engine produces some power. The power pulls the truck forward, and that's the force that's responsible for the motion. But there's also the accompanying friction between the tire of the truck and the ground. The friction opposes the motion. The friction, the direction of friction is backwards, that is against the direction of motion. So we have a graphical representation of acceleration and retardation. You see, is um, is acceleration takes place whenever velocity of a body increases with increase in time. So this should be the graph. The graph can also look like this. Okay, in both the cases, the velocity of the body is increasing with increasing time. But in case of retardation, the things are quite different. The body will have a finite value of velocity initially, and the velocity will decrease with increase in time. So the graph should look something like this. Okay. Um, Before looking at the friction part, let's have a look at the code. So this program incorporates acceleration and braking in my coding. The setup is again quite similar, but if I press the up arrow key and do not release it, the velocity of the ball keeps increasing. In this case, it has increased till 9.3 miles per hour, and I see a lot of throttle on written over here. If I press the down arrow key and do not release it, the velocity will keep decreasing. See, the velocity has decreased to 4.4 miles per hour, and I see a lot of brakes on. Till the time I was pressing the down arrow key, the brakes were on, and it got printed over here. So this program is much closer to our approach of the ideal car. The coding is just a modification of the previous program. The coding is just a modification of the previous program, um, but I have two new Boolean variables, throttle and brakes. If the throttle is on, it will get printed over here, and the brakes are on, they will also get printed over here. If the throttle is on, I'll increase the velocity by a preset amount ACC. ACC represents the acceleration. It is preset to 1. Sorry, it's preset to 0.1. If the throttle is on, I'll increase the velocity by ACC. If the brakes are on, I'll decrease the velocity by ACC. The rest of the program is quite simple to understand. And so we move on to the next program. But before running this program, I would like to take you all to OneNote for a bit of understanding on friction. Friction is the necessary evil. Friction is necessary because we can't do without it. It's evil because it's wasteful. It results in the loss of energy. Therefore, the velocity of the body will drop. Okay. In our program, we see friction as a form of retardation because friction causes a decrease in velocity. Friction will always occur whenever you will have motion. So if you have motion, there will always be accompanying friction. Next, we come across two graphs. In the first graph, we have only friction. The second graph incorporates both friction and braking. The first one can be looked upon as a car which is moving, but the throttle is not on. So in that case, the car gradually comes to a standstill. That's what I've tried to show here, that the car has some velocity. It keeps on decreasing until it becomes zero finally after some time, say over here. In the second graph, we incorporate both friction and brakes. The result is the same, that is the car comes to a standstill finally, um, but over here the car comes to a standstill quicker because both friction and brakes are responsible for slowing down of the car. So both are the cause of the retardation. With that, we see the code, we run it, and we have the code sculptor Grand Prix. The yellow ball is my Formula One car. I have my speedometer over here. I would like to point out three things in this program. The first one is that when I press the up arrow key, the car accelerates, and if I release the key, the velocity keeps on decreasing gradually until it will become zero. Now this decrease in velocity gradually is because of friction between the tires of the car and the road. If the car has some velocity, if I press the brakes, which is the down arrow key, the car comes to a standstill much more quicker, because in this case, both the brakes and the friction are responsible for the reduce in velocity. The third thing is that if I keep on pressing the throttle, the car's velocity keep on rising until it reaches or approaches a value that is the top speed of the car. Now the concept of the top speed of the car comes from the fact that friction caps the value of the velocity. So the velocity cannot increase more than a particular value for a given friction and given throttle. In this case, the velocity won't increase more than 98.999. So with that, we have a look at the code. The code is again a modification of the previous code, but we have a very important statement over here which says velocity equal to velocity into a small fraction. Now this is friction. This statement over here, when throttle is on, is responsible for capping the velocity of the body, and thus the concept of top speed of the car comes from here. I also have a similar line down under over here, over here. Now this statement over here is responsible for gradually slowing down the car when throttle equal to false. So if the car is not having any throttle, the car gradually comes to a standstill even if the brakes are not applied, and that is because of the friction from over here. The rest of the program is quite simple. Um, this is used to print all the lines and the text on the canvas. I have my key down and key up handlers for reading that which key I'm inputting, and that's the end of the program. With that, I would like to conclude the video, and I hope that you learned something from this video and you enjoyed it.